Good evening, ma'am.
Kavya. Kavya, are you there?
I'm there, ma'am.
Any doubt from the last class, Kavya?
No doubts, ma'am.
So today we will be going to complete the chapter that is electrochemistry, and we'll start with the new chapter that is the deep dive.
Okay.
What happened?
Nothing, ma'am.
So now I hope that you are able to solve the questions related to the electrochemistry.
Yes, ma'am.
So how much, if I say in percentage, that how much percentage you will be able to solve the question?
70 to 80 easy.
70 to 80%.
Hmm.
With accuracy,
Yes, ma'am.
100%.
Yes, ma'am.
Or you will be trying only those questions in which you are confident.
No, actually, I'm doing Abhi Avasti, I'm doing, so I can solve that questions.
Okay. The topic that we left in the electrochemistry was fuel cells and porosity, right?
Yes, ma'am.
First is fuel cells. So what are fuel cells basically? These are those cells in which we use the energy from the combustion of fuels basically. And that energy we use to convert it into electrical energy, right? What happens in the galvanic cell basically? In the galvanic cell, we were having the chemical energy with the help of chemical reactions, right? And that chemical energy is being converted into the electrical energy. That was happening in the galvanic cell.
Yes.
In the fuel cells, what is the difference? It is also a type of galvanic cell, but in this, the energy that we use is the energy from the combustion of fuels. And that energy we use to convert it into electrical energy. No chemical energies. So galvanic cells, got it?
Yes, ma'am.
That are designed to convert energy of combustion in place of chemical energy. Energy of combustion of fuels basically directly into electrical energy. Here,
Yes, ma'am.
what is the benefit of using fuel cell basically? It is pollution free because all the energy or the extra, or we can say the side products, we use in the form of energy to convert it into electrical energy. So no side products will be formed, no harmful gases will be released. And it is of high efficiency. As all the side products are being used in this reaction, so efficiency is high. Got it?
Yes, ma'am.
So basically what happens in this case, we have a chamber like this. Here I put a slide of my anode. This is my anode. I have made this one, and this is my cathode. Okay, got it. Here I placed a membrane that is permeable only to proton. So I call this membrane as proton permeable membrane. Got it? Permeable, you know what is permeable?
Yes, ma'am.
As it allows only the movement of
Electric.
proton from along it.
Oh, yes.
That anode and cathode we connect with a bulb. What was happening in the galvanic cell? We placed a anode compartment there, cathode there, connected by a bulb, and internally connected by a salt bridge. It was there in the galvanic cell, right? Is it?
Yes, ma'am. Yes.
So what happens in this basically, as it is the combustion of fuels. So in fuels, I always consider my hydrogen gas as that. Okay. So what I do basically, we pass hydrogen gas from here. As it is anode, it means oxidation will take place. It will be like this. As on anode, it is oxidation always, na?
Yes, ma'am.
So as there is the formation of proton and electrons, at the anode, I am having protons and electrons. Now with this permeable membrane, my protons will shift from this side to this side,
Yes.
and they move to the cathode, correct?
Uh-huh.
Now I'm left with my electrons. So electrons will do, they will pass over this from here to here. When the electrons move, the bulb glows. Now the electrons move back to the cathode in this way, because by this membrane, electrons are not able to pass. So they took another path, that is from this wire, bulb, and then wire. Okay.
Mm-hmm. Yes, ma'am.
Now what I do basically, we pass oxygen from here. So now I am having H positive and oxygen. So what they will do? They will form water.
Yes.
So when they will do form water, this water will be ejected out from this tube. And when water is getting released, a lot of energy will also released with the formation of water. Okay. So my main motto was to generate the electricity basically. So how it is generated? Hydrogen gas is passed over here. That hydrogen converts into hydronium ion and electrons are passing over here. When electrons are passing over here, my electricity is being generated. This is my main motto of the experiment. Huh?
Yes, ma'am.
Got it? So what is happening? H2 is converted into H positive. H positive are getting passed through the permeable membrane and protons are through the wire. And due to the movement of electrons from the wire, there is the current in the circuit that we call as electric or electrical energy is being generated.
Oh, okay.
Got it? And these
Yes, ma'am.
electrons are consumed by H positive to do the reduction. As on the cathode, there will be a reduction. So H positive in this case will accept the electrons and form H2. Now this H2 and this O2 combine to form water molecule. Got it? Or having any
Yes, ma'am.
doubt?
No, no doubts.
Well, next topic is corrosion. What is corrosion basically? Tell me. What is corrosion?
Corrosion is weathering away of metal bodies or reaction with oxygen something.
I'm not getting what you are saying.
Like corrosion of iron is basically reaction of iron with oxygen and moisture.
It is the rusting. When we talk about particular for iron, then we call it as rusting. But for other metals or a specific term, we call it as corrosion.
Okay.
Okay. So basically, it is the coating of oxide because oxygen is coming over here now. So oxide will form. So if a oxide of any metal get coated over the other metal, then we say that this metal undergoes corrosion. Got it?
Yes, sir.
Coating of surface of metal with oxide of metal. Got it? And these metals are different. When we talk about iron, we call it as rusting. When we talk about silver, Ag, we call it as tarnishing. Okay.
Yes, sir.
So from this part, basically, you get the reaction part, basically. The question came from the reaction, basically, the rusting of iron. So what happens in this case? As it is iron, so at the anode, what iron will do? Iron will undergo oxidation. As there will be oxidation on the anode, correct?
Yes, sir.
So this iron will undergo oxidation. Now, if there is anode, it means the cathode is also present there. What it will do, oxygen from the environment and H positive from the water molecule or the moisture from the environment, it will get converted into water. Okay. Because in the atmosphere, we are having oxygen and this H positive, we can say that it comes from the carbonic acid. Like in the atmosphere, I'm having carbon dioxide and water droplets as a moisture, basically, I can say. So what they will form? They will form carbonic acid. And this carbonic acid will release H positive ion. That H positive ion will react with oxygen and form water. Got it?
Yes, ma'am.
So this is the reaction that happens basically. So if we combine the two reactions, Fe plus O2 plus 4H positive, as it is 4H positive, so 4 electrons will be there and I have to multiply it by 2 Fe. It will give me 2 Fe2 positive plus 2 water molecule. Got it?
Yes, ma'am.
What these Fe2 positive will do basically, these Fe2 positive will react with this water in presence of oxygen. It will react with water that is formed and oxygen that is present in the nature to form Fe2O3, that is ferric oxide. This is basically responsible for the rusting.
Okay.
Got it?
Yes, ma'am.
Any doubt?
No doubt, sir.
Okay. So here your chapter has been completed. For the prevention, you know that to prevention basically.
Prevention is galvanization, then coating
Yeah.
them with paint.
Yeah.
And then
Electrochemical process is also there in which we coat the iron with any other metal to prevent it from rusting. And how we have studied the topic that is electroplating, in which one metal is coated over with the metal of another metal.
yes, some galvanization.
Yeah, yes. Okay, so how we do the galvanization by a process called electrochemical.
Electroplating. Yes.
Electroplating. Electroplating comes under electrochemical.
Yes, sir.
Okay.
Yes, ma'am.
So any doubt from the chapter, that is this one?
No doubts, ma'am.
So can we start with the D block now?
Ma'am, I had
For the
one doubt
D,
in this क्या बोलते हैं coordination geometry, coordinate geometry.
yeah, just ask.
Um, one minute, ma'am.
Hmm.
Yes, ma'am. The question is,
Hmm.
uh, find the given compound is cobalt, En, NH3 H2O.
Find the what?
Ma'am, the given compound is cobalt,
Hmm.
En, NH3,
Hmm. Hmm.
taken thrice, and then H2O,
Hmm.
hole under the ionic sphere, 3 plus.
What you have to find in this question?
First option is it will have three geometrical isomers if bidentate En is replaced by two cyanide ligands.
It will have three
Geometrical isomers.
isomers you have studied.
Yes, ma'am.
Hmm. Isomers.
If
If
En
En.
is replaced by cyanide.
Okay. Next.
Next is it has two geometrical isomers.
Hmm.
Uh, Option C is it is paramagnetic.
P1
Next option, paramagnetic.
is.
Paramagnetic.
Hmm.
And the final one is it observes light at longer wavelength compared to it absorbs light
Uh,
at longer wavelength compared to COEN,
Compared
cobalt,
to
cobalt,
uh,
En, NH3 taken four times.
NH3
Taken four times.
4 times. Charge
Hmm.
3 positive.
Three positive.
This one. Huh?
Yes, ma'am.
First one is it will have three geometrical isomers. We can have only two geometrical isomers, na? If it has been replaced by cyanide. So if it has been replaced by cyanide, then my if I replaced by cyanide, na, then my coordination number will be 5, right? So geometrical isomer is what? When we have the
No,
configuration
ma'am.
of cis and
Replaced by
trans.
two cyanides.
Okay,
En
two
is replaced by
cyanide.
two cyanides. Yes.
Okay, okay. About cyanide, cyanide. We can have NH3 and what? This one is a trans configuration and cis. So first one is incorrect. We know that why?
Ma'am, in the answer they gave it is correct. बोल के.
It is given correct.
Yes, ma'am.
Wow. Some facial or meridional is given or
No, no, nothing. These are the exact options.
So what you have to find basically in this case?
You have to check for the correct statements.
Okay. Because geometrical isomers are those in which we have the only cis and trans configuration. Na?
Yes, ma'am.
So if I'm replacing the H2 is of no use, we can place it anywhere. But if I say that NH3 is there, then I have the facial and meridional position over here. No cis trans will be there in this case.
Acha.
Cyanide, we can have this configuration. This one is the trans. Second one is incorrect.
Second one is correct, they give, ma'am.
See, either it will.
Second. Yes, ma'am.
Okay. Second is correct, right? Why it is correct? Because in this I'm having En. No, it will be, yeah, it is. No facial or meridional is mentioned over here.
No, no, nothing, ma'am. No facial, ma'am.
It will not show geometrical isomer. It will show optical isomer. Let's just check the third option. In the third one, what is the oxidation number for carbon you got? Cobalt plus 3.
Yes, ma'am.
Scandium, titanium. It is 3d6, correct? Correct?
Yes, ma'am.
When it is 3d6, 1, 2, 3, 4, 5, and 6 will be this one.
Yes, ma'am.
As in this case, I am having strong field ligand, nitrogen, nitrogen,
Mm-hmm.
right? If it is nitrogen and nitrogen is there, it means my strong field ligand is there. It means these electrons will paired up. Na? So this one will be diamagnetic. Correct?
Yes, ma'am.
So this option is incorrect. Got it?
Yes, ma'am.
But what answer is given for the third option?
Incorrect only, ma'am.
Incorrect. So if I talk about this one, absorbs light at longer wavelength compared to this one. Na?
Mm-hmm.
If I consider this one, in this I am having one strong field ligand and three strong field ligands. In total, 4 strong field ligands are there,
Yes, ma'am.
right? And one is weak field ligand. So in this case, I am having strong field ligand less than this one. Can I say this thing?
Yes.
Right. So if I'm having strong field ligand less and strong field ligand more, what happens in case of strong field ligand? My delta naught is greater than pairing energy,
Hmm.
correct? So in this strong field ligands are less. It means delta naught for this one. Okay. Suppose say I am giving it as a B name and this as A name. Got it? So delta naught for A will be lesser than of delta naught B. Can I see this? Getting?
Yes, ma'am.
Well, we studied one thing that more the value of delta naught, more will be the stability. So B will be the stable compound.
Okay.
If it is the stable compound, it means it is having more energy, octahedral energy, CFSE that we call.
Yes. Okay.
Yeah, it will have higher energy. B will have higher energy.
Yes.
Energy of B is greater than that of energy of A. Correct? And it is the CFSE energy that we are talking about. So energy is related to H nu. Correct?
Yes, ma'am.
H nu is Hc by lambda. Lambda is your wavelength.
Yes, ma'am.
Correct? If its lambda is inversely proportional. Now, so if I write it as, can I write this thing as this one? Got it?
Yes. Okay. Yes. Easy. Yes, ma'am.
Right? So that's why A will have the longer wavelength as compared to the. What's the answer given to you for the D option?
Yeah. Correct answer, ma'am. D is correct.
Correct. Okay.
Okay.
Just let me check for the A and B. Huh?
Yes, ma'am.
Just give me 1 minute. Let me
Yes,
check.
ma'am.
Now get to know that why the option B is correct. Just here I am having this one. So as the coordination number is 6, so my complex is octahedral. Got it?
Yes, ma'am.
My one complex is this one. And in other what I can do is can I do this thing? So in the first case, water with respect to En is in transposition as NH3 position doesn't have any impact. Because in this case, I can say NH3 is cis, and in this case, I can say same case, it is trans. So it remains always in the same.
Yes.
So my only change that can happen only is with water. In this case, water is adjacent to hyaline diamine, and in this case, it is trans to this.
Oh,
Maybe that's why it is saying that two mechanical isomers are.
okay.
Okay. The
Yes,
third one
yes, ma'am.
is when En is replaced by 2-cyanide.
Hmm.
when we replace the En with the 2-cyanide, is this one now, correct? One case that I can write is the trans with respect to cyanide, and one is the cis with respect to cyanide, correct?
Yes.
This is my water suggestion. Is the third structure. There I'm not getting that. Why is he giving that 3 structures are there? First, the one that I have drawn is the basically the trans one. That is this one. In the trans one, no other possibility is over here. If I draw the structure, that is the cis one is in which all the nitrogen are the same position, and one I can draw this one, NH3, NH3, NH3 over here, and water is here. This is the same structure that maybe these 3 structures he has given. See, one is the trans one, cyanide and cyanide opposite to each other. In this case, it's the only, there's no other possibility than this structure. If I draw the trans structure, either I put ammonia in this sequence or in any other sequence, 2 ammonia will be adjacent to each other. If I replace their position, then the structure will always remain the same, correct? Are you getting? Kavya, are you there?
Yes, ma'am, I'm there.
Yeah. In the second case, that is the cis one, when I have placed the cis cyanide, in the one case, I have put all the ammonia adjacent to each other, and in the cis one, in the other case, I have put water in between the ammonia. These structures are possible. One by the trans configuration and 2 by the cis configuration. That's why he's saying that 3 geometrical isomers.
Acha.
Okay.
Yes, ma'am.
Any other doubt?
No doubts, ma'am.
Done?
Yes.
Now we will start with D block. For the D block, we will have a quick revision and move to the depth, that the topic that you have demanded for. Okay, like the
Yes.
potassium permagnetite type. So
Yes, ma'am.
basically, what are D block elements in which the last electron enters D subshell, right?
Yes, ma'am.
D block elements are also called as transition elements.
Yes.
Why transition? And when we call D block element as a transition element?
Because they have incomplete orbitals.
Yeah, incomplete d orbital either in its ground state or in any excited state,
Oxidation state. Yes, sir.
right? So
Mm.
I can write like partially filled d orbital in ground state or in any
Oxidation state.
excited state. Correct?
Yes, sir.
If I talk about the 3D series basically, that is basically scandium 2, zinc. The last electron of this, that is zinc. Below it, there is cadmium and mercury. All these have the D10 configuration. No partially filled d orbital in ground state or in oxide state. That's why we call that these elements are not transition elements. Right? Correct?
Yes, sir.
D block elements have the configuration of D from D1 to D9, as D0 and D10 are not the transition elements.
Okay.
Got it?
Yes, sir.
Their general electronic configuration is N-1, D 1 to 10, and S 0 to 2. Why 1 to 10 I have written? Because it can be D10 configuration in the ground state, but in the excited state, maybe it is possible that it has the partially filled d orbital.
Yes, sir.
Right? That's why I write it as D 1 to 10 NS. Most of the cases we find always that configuration for S is NS2, but NS0 and NS1 we write in some exceptions where we get the maximum stability. Like we say that it is becoming full filled, that's why we write it as NS1. It is becoming half filled, that's why we write it as NS1 or NS. Correct? Like we say chromium is there, copper is there. What is the atomic number for chromium?
25. Wait.
Oh.
24, sorry.
For copper, it is 29. So if we
Yes.
write the configuration for it, it should be
4s1.
3D4, 4s2. And for
But
this, it
4s1
should be
3d5.
3D. It should be this one. But for
Yeah.
the extra stability, we write it as like 3D5,
And
4s1,
4s1.
and 3D10.
4s1.
So there are the exceptions basically. For NS1, you have the exceptions of this one. From 3D series, from 4D series, you have the exception of niobium, molybdenum, and ruthenium. Rhodium, palladium, and silver is also there. And from the 5D series, you have platinum and gold, in which we have the configuration that is NS1.
Okay.
Got it?
Yes,
For
sir.
NS0 configuration, we have only one element among the D block, that is the palladium. Okay. Remove palladium from here. Palladium comes in this. Clear?
Yes, sir.
Because in the examiner, mostly exceptions are being generally asked.
Okay.
When we move from left to right, what happens basically? Size decreases. In a general trend, if I talk about
Yeah.
from the like general trend of size in a periodic table, it is the
Yes,
size
sir.
decreases when we move from left to right.
Yes, sir.
But in case of 3D series, what happens basically? Size decreases to some extent. Cadmium, titanium, vanadium, chromium. Right? For manganese, it decreases. Then iron again decreases. And for the 3, it remains the same. Do you know that why?
Because
It is
of
the order.
So,
What?
the shielding
What?
effect.
Yeah, it is the shielding effect and the nuclear charge. Because as we move from left to right, one effect starts dominating over the other. That's why our order gets reversed.
Yes.
Correct?
Yes, ma'am.
Okay. Then we have the trend of ionization energy. When we move from left to right, what happens with the ionization energy? We will just do a quick recap or the brush of the chapter, that is the D block. Okay. So if
Okay.
anywhere if you found out that one this topic should be in depth, then just tell me. Then I will give you the detail of that topic.
Yes, ma'am.
Okay. So as we move from left to right, what is the change in the ionization energy?
It increases
Yeah. Why it increases?
because effective nuclear charge increases.
Yeah. But for the some cases, first ionization and second ionization are different. So there are the exceptions that I have noted for you. One is this one. The first ionization enthalpy for manganese is higher than that of this one. But for the chromium, the second ionization energy is higher. Why?
Because second way it will have to remove an electron from 3d5
Yeah.
half filled
So
electron.
that's why its second ionization energy increases. Then next
Yes.
we have the exception, that is copper and zinc, whose first
Same.
ionization energy will be higher and whose second will be higher.
First ionization will be higher for zinc.
Okay, and second,
Copper.
for manganese and iron.
Manganese 4 is to 3d5, 4 is to 3d6. Uh, it will be higher for iron.
Okay.
No, wait,
Second,
sorry. First one iron, second one again iron.
third,
Third, four is to 3d5. Three manganese.
okay. So these are the exceptions basically. Next is the D block elements form alloys. Okay.
Yes, sir.
So the alloys that are formed from the D block element is first is the basically the brass. So what are the metals present in brass? Which D block elements are present in brass?
I don't know. Iron, iron, nickel,
Copper and
copper.
zinc. This you should have to remember.
Okay.
Next is the bronze, where we have copper and tin.
Uh-huh.
These are the D block elements. Last one that you have to learn is the German silver. Copper, zinc, and nickel. Okay.
Yes, sir.
The next property for D block elements is basically that D block element form interstitial compounds. What are interstitial compounds?
Compounds that are mixed with H, C, and N.
Yeah, H, C, N, and boron are also. These are trapped into the voids basically, the small gaps, small gaps.
Yes.
What type of compounds basically? As these are non-stoichiometric, like it can be given to you that you have to choose the correct option, like the way that you have asked me the question. The
Yes, ma'am.
interstitial compounds that are formed are non-stoichiometric. These are generally hard than pure metal. Okay.
The higher boiling and melting point.
Yeah. Melting and boiling point is high, but the conductance remains the same.
Yes, ma'am.
And they are chemically inert. Is chemically
Yes.
unreactive. The next property that the d block elements show is basically the magnetic movement. As we have seen, that if there is the presence of unpaired electron, then my compound is paramagnetic, otherwise it is diamagnetic.
Yes, ma'am.
Right?
Yes.
We can calculate the magnetic movement by under root n plus 2. N is number of unpaired electrons, and its unit is Bm. That is for what is it?
Sorry, ma'am.
What is M?
For magnet something.
Magneton.
For magnet.
Okay. Next is basically the melting point for d block elements. As the d block elements, as we move from left to right, the number of unpaired electrons increases. As the number of unpaired electron increases means atomic interaction increases or the nuclear charge increases.
Yes.
If atomic interaction increases means melting point increases. Or we can say that atomization enthalpy also increases. Correct?
Yes, ma'am.
If we talk about among 3D, 4D and series or 5D series, as we move from top to bottom, okay? As we move from top to bottom, my interaction decreases. So the melting point order will be this. Okay.
Yes, ma'am.
The element that have the maximum melting point in D block elements, element with maximum melting point, D element basically, D block element with maximum melting point, that is the tungsten that you have to learn.
Yes, ma'am.
If we talk about in a series basically, either 3D, 4D or 5C, in a particular series, the one with the highest melting point is the
4D.
element that, sorry,
Nothing, sorry.
okay. In this series, the one with high melting point belongs to sixth group. Like in 3D series, if I say that it is sixth group means total number of outermost electrons will be 6. Correct?
Yes, ma'am.
So which element has the outermost electrons as 6? Will be chromium. That is 3D4, 4s2.
Yes, ma'am.
It belongs to
No,
the sixth.
4S on 3D, fine.
It is the exception. Huh? So general one is
Okay.
okay.
Yes, ma'am.
Next, we have a property of showing variable oxidation state. D block elements show variable oxidation state.
Yes, ma'am.
Why they show variable oxidation state?
To attain more stability.
No, because in this now ns and n-1 d orbitals have almost the same energy. That's why both the orbitals participate while bonding. So the total number of electrons in the outermost shell increases. You are seeing over here now that it is the 3d and 4s1 is there. So the energy of s and n-1 d orbital are almost the same. If it is same, so number of electrons that we can count increases. So due to the availability of more number of electrons. And why the energy of these are same? Because there is very, very low gap between the energy of these orbitals, 4s and 3d. Okay.
Yes, ma'am.
So these show variable oxidation state due to every availability of electrons basically. And why these are available? Due to low energy gap between Ns and N minus 1D. Okay.
Yes, ma'am.
So the element in the 3D series that shows the maximum number of oxidation state is which one?
Manganese.
Manganese. Okay. It shows
Yes.
oxidation state of +2 to +7.
7.
Basically, what happens when we move from scandium to manganese? My oxidation state increases. Scandium show only +3, shows +7. It increases and then it again starts decreasing. Okay.
Yes, ma'am.
Basically, these are the properties of D block elements that you have to study or just to revise once. And rest of the things we will do tomorrow. You can have a quick revision of these notes.
Yes, ma'am.
If you want any topic from this one to be in depth, then let me know.
Okay, ma'am.
Because we have time, no? It is 3rd May and you have 15 days left.
Yes.
So we can do.
Yes, ma'am. Thank you, ma'am.
Scroll down.
Yes, ma'am. Yes, I'm still ma'am. Yes, I'm still ma'am. Scroll down. And down, ma'am. And down. Yes, ma'am. Yes, ma'am. Yes, I'm still ma'am. Yes, ma'am. Done. Yes, ma'am.
Eh?
Yes, ma'am.
Any topic you want to be in depth?
No, no topic.
It's the last chapter now you are left with.
Yes, ma'am.
Rest of the topic we will do tomorrow.
Okay.
Okay.
Yes, ma'am. Thank you.
Okay.